Exercise 14b. Paolo was traveling in his car to a meeting. The distance time graph alongside illustrates his journey. How long after he set off did he stop for his break, set off after his break, get to his meeting place? Okay, before we continue with this exercise, you do need to bear in mind the distance, speed, and time formula. So if we just draw the distance, speed, and time triangle, which you've probably accustomed to seeing by now, DSTV as I like to call it, distance equals speed times time. Just using lowercase letters here. Distance equals speed times time. And you need to remember this, right? And it's easy to work out as well. If you are traveling at 100 kilometers per hour, what that means is every single hour you are covering 100 kilometers. This is your average speed. So you can always work out, even if you don't remember this formula, you can always work it out from speed. So speed equals distance divided by time. How long after he set off did he stop for his break? Now, on the y-axis, we have the distance covered, and on the x-axis, the time taken in hours to cover that distance. So, to find out how long after he set off at this point, 0, 0, obviously. How long after he set off did he stop for his break? So, if we just look at this graph, after 1 hour, he has covered 40 kilometers. After 2 hours, go to this point up here, he has covered 160 kilometers. The reason that this section of the function is steeper just means that he's increased his speed. A steeper line represents an increased, higher speed. So after 1 hour, if we just look at the graph, he's covered 40 kilometers. That means that the speed is 40 kilometers per hour. After 2 hours, the distance covered is 160 kilometers. So the average speed will be 160 divided by 2 is 80 kilometers per hour. So we can clearly see that the speed has increased. If we call this point A and that point B, let's rather call the starting point A after 1 hour B and after 2 hours C. Then between B and C is clearly picked up his speed, he's increased his speed. Now, how long after he set off did he stop for his break? If he stopped for his break, that means he's no longer moving. So his speed is 0. In other words, the fact that he's not moving, his distance hasn't changed at all over a period of time. So if we just look at the flat line on this graph between C and D, right, he stopped for a total of 1 hour, between 2 hours and 3 hours. After starting his journey between 2 hours and 3 hours, he's not moving at all, right? So how long after he set off did he stop for his break? You would say after 2 hours. And if you want to go further, you would say that he stopped for an hour. How long after he set off did he set off after his break? So this would be after 3 hours. Again, implying that he had stopped for an hour. So 3 hours after he set off on his journey, did he then resume his journey after the break? How long after he set off did he get to his meeting place? So his meeting place would be after 5 hours, because that's where the graph ends, right? So this would be after 5 hours. At what average speed was he traveling over the first hour? Okay, we've already answered that. So after 1 hour, he's covered 40 kilometers. So the speed is 40 kilometers per hour. At what average speed was he traveling over the second hour? So after 2 hours, the average speed is 80 kilometers per hour. So his average speed over the first 2 hours is 80 kilometers per hour. But this question is asking what the average speed was over the second hour. In other words, we are looking at the speed between B and C. So we need to take into consideration how much time what the time taken was to get from B to C, which is 1 hour, and the distance from B to C is 40 to 160. So the distance covered is 160 minus 40, which is 120 kilometers. So the average speed over that 1 hour between the time taken from B to C is going to be 120 kilometers over 1 hour, which is 120 kilometers per hour. At what average speed was he traveling for the last part of his journey? So the last part of his journey is this segment highlighted here. So the time period in that interval is between 5 and 3. So that's 2 hours. And the distance covered is from 160. The distance covered after the break, 160 kilometers to 240 kilometers. So the difference here is 240 minus 160 is 80 kilometers. So 80 kilometers over 2 hours. So the average speed is 80 kilometers over 2 hours, which is 40 kilometers per hour. The meeting was scheduled to start at 10:30 a.m. What's the latest time he should have left home? Okay, so he starts the journey at 0 and he gets there after 5 hours. So if the meeting was scheduled to start at 10:30 a.m., he needs to be there by 10:30 a.m. So if it takes him 5 hours to get there, he should have left home at 5:30 in the morning. Question 2. Farid was traveling by car in Europe on his holiday. The distance time graph below illustrates his journey. His greatest speed was on the motorway. How far did he travel on the motorway? Okay, so if his greatest speed, it doesn't matter where his greatest speed is, the location is not relevant to the problem. We're talking about the greatest speed, which is the only relevant part of this question. The greatest speed is the steepest part of the graph, okay, because the steepest part of the graph represents his greatest speed. The greater the speed, the steeper the distance time graph will be. So that will be, if we mark the starting point off as A, and then at each point we just mark B, C, D, etc., then the steepest part, the steepest part of this journey is between C and D. So how far did he travel between C and D? Well, at C, he had traveled 75 kilometers, and at D 200. So this would be 200 kilometers minus 75 kilometers, which is 125 kilometers. What was his average speed on the motorway? So now this section CD, we want to know what his average speed was. So we're looking at essentially looking to find the gradient, right? So the time taken was between 3 p.m. and 4 p.m. So that's 1 hour. And his distance covered is 125 kilometers. So the average speed for the section is 125 kilometers, and it took 1 hour to do that. So his speed was 125 kilometers per hour. When did he travel the most slowly? So that would be the shallowest section of the graph. So where it's quite the opposite of the steepest part of the graph. It's the shallowest part of the graph. It's not AB, it's not DE, it is BC. So when did he travel? So the time taken is between 2 p.m. and 3 p.m. Between 2 in the afternoon and 3 in the afternoon. What was his lowest average speed? Well, the lowest average speed, we want to know what the speed was for the section BC. So in 1 hour, he traveled at B, it looks like it's exactly between 50 and 75. That's going to be 62.5 kilometers to C, which is at 75. So the total distance is 75 minus 62.5. It's going to be 12.5 kilometers, and that's over 1 hour. So just moving up here, the average speed between B and C will be 12.5 kilometers over 1 hour. So it's 12.5 kilometers per hour.